Alright, on to the last one. This is the last section that we have for AP Statistics. You guys can see the finish line, and you are almost done. So, let's look over this. Again, we're talking about slopes, but this time we're looking at the hypothesis test for slopes. So last time we looked at the confidence intervals, and now we're looking at hypothesis tests. This isn't a major part of the AP exam, but there is a possibility that you will get questions with it. But it's less than like 10% of the overall exam that you're going to get questions on this section. So it's not a major one, but you can get questions on it. It's like if you take an AP Calc, it's like slope field. It's not a huge thing, but slope fields are easy points. So let's learn about these hypothesis tests for slopes. Okay, so general significant test. Again, this is following the normal significant test that you guys have been doing for months now. Hypothesis, test statistic, plan, state, do, conclude, etc., etc. Find the p-value, compare it to everything else, all that stuff. So general hypothesis, okay, the HO or the null hypothesis is going to be that beta is equal to whatever the stated beta was or the stated slope was. Alternative hypothesis is where you say that it was greater than, less than, or not equal to that number, okay, depending on if they think it's less than or more. The test statistic is the b value minus the suggested one, so the slope founded, or the slope found, minus the slope stated, all over the standard error of the standard of the slope. Okay, which most of this you're not going to be doing by hand. Okay, there's a very good chance that you will not have to do this one by hand. We are going to go through one that you do it kind of all by hand though. Okay, and then the p-value you're using as a df of n minus 2. So just like the previous one when we talked about doing your n value, or your df is n minus 2, same thing here, because there is the two sets of data. Okay, so on your calculator can do this t-test for slope. It is under stat test, letter F. This is on the TI 83s, 84s. LinReg t-test. So previously we looked at the interval one as well. X1 is your, or X-list is your X-list, which is usually L1. Y-list is L2. Frequency 1. You pick which one you're stating, which is again usually your beta here. And then the regression equation, which you can keep blank. You don't have to type anything in on that, but you can highlight whichever one you want. And then your calculator is going to give you all the key pieces of information you need from that. So why do we do this test? It answers the question is, does the sample suggest there's a linear relationship between two variables? And how can we determine if this happened by chance or if it's an actual linear relationship? Okay, so this is doing the actual test of it. So unlike the interval, which is telling you the range of numbers, this is saying, is it this number or not? And that's what this is doing. Okay, so that's the question that we are answering here. Okay. All right. So here's an example. We're going to do this one by hand. It's going to be a huge pain in the butt, but I think we should be fine with it. We got 2 examples, and then we're done. Okay, so let's run through this one. We're going to go through our state, plan, do, conclude on this. So starting off with state, you state your null and alternative hypotheses, and you state what the beta represents. So in this case, the beta represents the true regression slope between hours slept and their GPA for the students. We said it was equal to 0. Okay, it's usually equal to 0 because we want to see if there's a linear relationship, and if it's not 0, then it is a linear relationship. So that's why we usually set these equal to 0. The alternative hypothesis is that it's not equal to 0 because we don't care if it's a positive or negative. We just want to know, is there a difference? It doesn't matter which is which. Okay, so there's our state. Now we go under plan, which remember is linear. So there's the 5 things that we have to check off. First one is it linear? So you check the scatter plot. It looks like there's a weak positive relationship, okay, which your calculator can do this. You plot it under L1, L2, and then you scatter plot it. So second y equals, set up the stat plot, and it should be able to do it. Next up is independent, which 14 is less than 10% of all seniors at a high school. Okay, so this high school, I mean not a small high school, because 10% of, if you had 14 out of 10%, that'd mean 140 seniors minimum. So yeah, so less than 10% met. Is it normal? You check the histogram of the residuals and you want to see if there's any outliers or skewness. There's what it looks like. It doesn't have to be perfect. You're just looking for the general shape of it. Looks like right there. Next up is the equal standard deviation. So this is where you look at the scatter plot and you're looking for any type of pattern that is up there. Doesn't look like there's any pattern for it. So you can move on to random, and it's stated that it is random. Random sample was used. Okay, so boom, 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 we hit everything. Now, the reason why you probably won't see a question like this is because of the time it takes to hit all these marks. Trying to draw the scatter plot, sketch the histogram, do the residual plot. All that stuff takes some time. If you have something like this, they might give you everything, or they just use the mini tab. The mini tab gives you more information than you really need for this. Okay, so, and we'll do an example of that with the mini tab. After that, you do the do. So in this case, since you just have the raw data, it takes a little bit more work because you have to find the key things. So data goes into L1, L2, one var stats on the L1, and the key thing you're looking for here is the SX. Okay, the SX is the key thing because you're going to use that in the standard error of the beta. Next, you go to stat test, linreg, the interval one. You don't even have to use the test one. You can use the interval one, and that's going to tell you the t value, the p value, the df, and also the b. So you don't even have to do a linreg. You can do that, and it tells you all those other pieces of information. Okay. Next, go back to your list. Go to L3. Highlight L3 on your list. You push second stat. Go all the way down to resid, which is the very last one. Then push enter, and that's going to give you all the residuals. And then the last thing you do is do one var stats with the L3 now instead of L1, and you write down the SX of that one. Okay, and that's going to be the residuals standard deviation. Okay, so those are your numbers that you need, and if you have gone through all those and you typed all those numbers in and everything, this is what you would have. So 0.173 over 1.15 root 13 is equal to that number, and then you take the difference, which was basically the b value, divided by whatever that standard error was, and that got you 2.44 and a p-value of about 0.0308. Again, a lot of work. You're probably not going to have to do all this for an AP exam. Okay, this is a lot of extra work, but this is how it's done by hand. Okay, now with a p-value like that, would you reject or fail to reject? Our alpha was 0.05, just to remind you. We would reject that because 0.0308 is smaller than alpha 0.05. So we reject it, which means that we do have convincing evidence of a relationship between the hours of sleep of a student and their GPA. Okay, so again, you probably won't have this type of an example because of all the extra work and the time consumingness of it. You will probably have an example like on the next slide. Let's do another example. I know that was a lot, but here we go. Okay, last example. So here's the output of a regression between the social studies concepts and reading comprehension scores of 25 random sophomores. Okay, so remember there's key pieces here that we need, there's key pieces that we don't need from this. Okay, so three-part question. First one, identify the values of the standard deviation, the residuals, and the interpret this value in the context of the problem. Second one, identify the values of the estimated standard deviation of the slope and interpret this value in the context of the problem. And C, carry out a hypothesis test with these data and interpret the results in the context of the problem. You may assume that the necessary assumptions are satisfied. That last sentence there is amazing, because under the plan, all you got to do is write all conditions are met because it's stated. So we don't have to go through the linear Linear, or liner, whatever you want to call it, process. Okay, so let's start with the first one, identifying the standard deviation and identifying the value of the estimated standard deviation of the slope. So before we interpret it. So if you're looking for the standard deviation, of the residuals, okay, that is the S value. So right here, that is the standard deviation of the residuals, is down here. Okay, so 25.83 is the standard deviation of the residuals. For B, identifying the standard deviation of the slope and interpret it, okay, that is this right here, the SE coefficient, but under the reading part, okay, not the constant. We want the slope number. Okay, so the slope in this case is 0.7, which you can see up here, 0.731, 0.731, and we'd want to look at the standard deviation, which is right next to it. Okay, so that's the standard deviation, the estimated standard deviation of the slope. Now let's interpret these. Okay, so that's the value. If you interpret it, it basically is telling you that the observed social studies scores vary from the predicted values by about 25.83%. Okay, so this is the formula, the equation on the previous, the linear equation, and how much do those scores differ from what they're predicted. So how far are they off that line? And the standard deviation of those is about 25.8 percentage points, or points in general. I don't know how they're scoring it, but 25.8 points off of that line is what this is meaning. Okay, so the residual, again, the standard deviation of the residual is telling you basically on average how many points off of the predicted line are the actual scores. Okay. Under B, we had to do the estimated standard deviation of the slope and interpret it. So basically it means that if we kept doing this this sample over and over again with 25 random sophomores, etc., the regression line, the slope in particular, would vary by about 0.0351. So it's not very large of a difference. 35 thousandths or 3.5 hundredths of change in it. Okay, and that's what the standard deviation, or the estimated standard deviation of the slope tells us, is how much is it going to fluctuate left or right, which in theory it shouldn't move more than about 2.5, 3. It shouldn't move more than 3, either above or below whatever the standard deviation is. Okay. All right, last but not least is C, which wants us to do the test. Okay, so our null hypothesis is that it equals 0, because 0 is the key thing here. Alternative is that it doesn't equal 0. Beta represents the true regression of the slope between social studies and reading scores. So there's our state. Our plan, all conditions are met because it's stated. Done for plan. Now we move over to do. And so now with do, the nice thing with this mini tab that was given is it tells us all of our pieces that we need. We need the B and we need the SE sub B. Okay? Which the B and the SE sub B are right next to each other. Okay? If you go back to the table, it's these two numbers right here. Okay? These two numbers. You take the coefficient of the slope right here, reading, and you divide it by the SE. Okay? And that's going to tell you what your T value is. So the T value here was about 20.84, which is huge. And then state your DF, which you just take the sample, 25 minus 2, and then your P value, which in this case is less than 0.0001, which again is stated right here. So in this mini tab, it tells you what the P value is. Okay. and you can use that. And since that is so low, we would reject the null hypothesis, and we'd say there's a good convincing amount of evidence that there is a linear relationship between the social studies scores and the reading comprehension scores. All right. Hey, that's it. All right. So we are done with everything. This is your last video for it. And yeah, next thing is just reviewing and getting ready for that exam.